Next time you're at a railway crossing, don't look at the rails or the wooden beams. Look at what's underneath all of that. Stones. Millions of rough, angular gray stones stretching in both directions as far as you can see. It doesn't matter if you're in Japan, Germany, or the United States. The stones are always there, always the same. And almost nobody ever asks why. Why rest multi-million-pound locomotives on a loose bed of rocks? Why not pour a concrete foundation and bolt the tracks directly to it? Surely that would be more stable, more permanent, more modern. The answer is more interesting than you'd expect, and it connects modern railway engineering to something that has nothing to do with trains at all. The core problem: a fully loaded freight train is almost incomprehensibly heavy, hundreds of thousands, sometimes millions of pounds of steel, fuel, and cargo moving along two thin strips of metal. If you place that kind of concentrated weight directly onto the earth, the ground would compress, the soil would shift, and the tracks would sink and buckle. A derailment wouldn't be a matter of if, it would be a matter of when. The stones, formerly known as track ballast, exist to solve this problem. Think of the railway as a layered system. Steel rails on top. Beneath the rails are the sleepers, those horizontal beams running perpendicular to the track, and beneath the sleepers sits the ballast. Its job is to take the enormous downward force of a passing train and spread it across the widest possible surface area, so no single point of ground absorbs too much pressure. Here's what surprises most people. The tracks aren't actually anchored to the ground. No deep bolts, no permanent fixtures. The entire structure sits on top of the ballast, held in place purely by friction and the collective weight of the stones. This gives the track a small amount of flexibility, enough to absorb vibration and shock rather than cracking under the stress. Why these specific stones? Pick up a piece of railway ballast and you'll notice it's unpleasant to hold. Sharp edges, irregular shape. Nothing like the smooth, rounded pebbles you'd find on a riverbed. That's completely intentional. Smooth stones roll, pack them under a vibrating load, and they shift, slide, and scatter, taking the track with them. Sharp, angular stones behave completely differently. Their jagged edges interlock when packed together, creating a dense mass that resists movement in every direction, even when a high-speed train is hammering through a curve at full load. The material matters too. Railway ballast is typically crushed granite or quartzite, among the hardest rock available, because it needs to keep those sharp edges over years of use without grinding down into smooth, ineffective pebbles. More than just support weight distribution is only part of what the ballast is doing. Water is one of the biggest threats to any railway. A solid concrete foundation sounds sensible until heavy rain arrives. Water pools with nowhere to drain, sitting against steel rails and accelerating corrosion. Bare earth is worse, turning to mud that shifts and washes away, leaving track without support underneath. A bed of angular stones is naturally porous. Water passes straight through the gaps and drains away immediately. The ground beneath stays dry and stable regardless of rainfall. The ballast functions as a built-in drainage system running the full length of the line. It also suppresses vegetation. That thick layer of sharp, densely packed rock makes it nearly impossible for plants to establish roots, and plant roots slowly breaking up soil beneath a railway are exactly the kind of invisible damage that undermines track stability over time. Weight distribution, vibration absorption, drainage, weed suppression, all at once. No moving parts, no power source, minimal maintenance. Where the word comes from, the term ballast is actually borrowed from sailing. Centuries ago, cargo ships sailing empty to collect goods rode dangerously high in the water, too light, too unstable. To stabilize them, sailors loaded heavy stones into the bottom of the hold. When the ships reached port and took on actual cargo, the stones were thrown overboard or piled up on the docks. Early railway engineers, searching for cheap and abundant heavy material to stabilize their new track beds, found these piles of discarded ship stones sitting at ports across the country. They were exactly what was needed. The stones moved from ships to railways, and the name came with them. Those gray rocks you've walked past 1,000 times are carrying the full weight of modern rail travel, draining every rainstorm away from the track, locking together against lateral movement, and carrying a name borrowed from the age of sail. Not bad for a pile of rocks.